Hey y'all, it's me, Miss B. Today we're talking about the unit circle and trigonometric functions. So we kind of already talked about the unit circle. So now we're going to define these functions based on the graph of that unit circle. So I'm just going to draw a little picture off to the side here. Nice and tiny. So here's my graph maybe. Okay, so here is my graph, and I'm just gonna draw circle. How do I make this see-through? Style, fill, none. That's awesome. Okay, so it's a little crooked. It's kind of annoying. Oops, dang it. There, that should be straight now. Kind of straight. Okay, so this from here to here is 1. Okay, so that's what makes it a unit circle. So this point right here is 1, 0. And this point up here is 0, 1. Okay, so I'm just gonna draw a little picture here. So let's just call this, we're just gonna draw a little triangle. Let me make my pen a little smaller. I'm gonna draw a little triangle. Could be any kind of triangle, really. So it creates a right angle, and this angle right here is theta. So from here to here, that's what's making our angle. This will always be a right angle, and this could be any point on this circle. It could be anywhere on here. So this point right here, if this is x and this is y, whatever this value is, this is going to be our x value for that point. And this point right here is our y value. So this point is always going to be x, comma, y. Oh, shoot. Something else I want you to notice is that if we were to look closely at this triangle, and this is, so then this is x and this is y. Let me use maybe a different pen color. So this is my x and this is my y. Then my sine is always opposite over, we're kind of far away, is opposite over adjacent. So my opposite side of theta is y, and my adjacent side, or it's hypotenuse, not adjacent. Oh, man, struggling. So my opposite side is y, and my hypotenuse is just 1 because it's a radius of the same circle. And so sine is equal to y over 1, or just y. Similarly, cosine is equal to x. So this is opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. So this is y over 1 and this is x over 1. Then tangent is equal to y over x. Okay, and then cosecant is 1 over sine, so cosecant is 1 over y. Cosine is 1 over x, and cotangent is x over y. So here, let's do our first example. I have this here. It says this point is 1, 0. And so then this point here is negative 3 over 2 and negative 5 over 2. So sine I'm just going to draw this up here. Feel like it's different than mine. Okay, so sine is going to be the opposite over the adjacent side. So if we are looking here, and this is our theta, our opposite side is this one here. So it's our y. And this is our x. So our opposite side is y, or -5 over 2, and then our adjacent side is 1. So for sine, we get -5 over 2. Cosine is then x, so it's 3 over 2. Tangent is y over x. I'm sorry, sine over cosine, or y over x. So it's going to be -5 over 2 over 3 over 2, which is the same thing as -5 over 3, if you simplify that. Cosecant, secant, and cotangent are easier to find because you just flip the fractions. We get -2 over 5. Goodness. 2 over 3, and -3 over 5. All right, sometimes, this is a separate problem, sometimes it gives us what two values are, and so then we have to find the other 5. So if I have, I'm just going to write out all of them. Gosh, I always trouble. Cosecant, secant, cotangent. There we go. Okay, so sine of theta is 3 over 5. We already knew that. Cosine is 4 over 5. Also, we already knew that. So then tangent's easy to find. It's just sine over cosine. So 3 over 5 over 4 over 5. So therefore, tangent is 3 over 4. And then the rest of them are easy to find because it's just the inverse of those. So 5 over 3, 5 over 4, and 4 over 3. Okay, go ahead and do this next one on your own. So sine is 2/3, cosine is radical 5 over 3. So then tangent is 2 over radical 5. We don't like radicals in the denominator, so we're going to multiply by radical 5 over radical 5. So we get 2 radical 5 over 5. Cosecant is 3 over 2. Cosine is 3 over radical 5. Again, we don't like radicals in the denominator, so we multiply by radical 5 over radical 5 and get 3 radical 5 over 5. Then cotangent is, we can just take the inverse of our original radical 5 over 2. That way we don't have to undo all the math we just did. Okay, so where's our unit circle? Oh, we don't have one. Why don't I have my unit circle on here? Let me draw one. Okay, that's good enough. So we want to fill in this unit circle. And here's our x and y, where cosine is x and sine is y, just like we talked about before. So these points are easy. We've got, I hate how small this pen is. We've got 0, 1, and 1, 0. This is negative 1, 0, and 0, negative 1. All right, I want you to go ahead and fill in the rest of that on your own. Okay, so something I do want to note is that for a unit circle, the domain of sine is negative infinity to infinity. And the domain of cosine is negative infinity to infinity as well. But the range of sine, it only goes between 1 and negative 1 because it keeps going around and around the circle. It never gets outside of 1. It just keeps going between negative 1 and 1. So our range is negative 1 to 1, as is for cosine. Okay, so let's do some filling in here. You will need to memorize these. Okay, so even and odd, basically what you need to remember is that if you put a negative in, then you're probably going to get a negative out. The only ones where that's not true is cosine. So if you look at cosine, if you put a negative in, you're going to actually get a positive out. Same thing with secant because they are like brothers. So the rest of these, you'll just get a negative sign out for that angle. Let me show you what I mean by this. I'm going to do an example off to the side here. So if I were to say, what is sine of negative pi over 4? Well, pi over 4 is radical 2 over 2, but since it's negative, I know it's negative radical 2 over 2. So basically, I'm saying I'm taking negative sine of pi over 4, which is negative radical 2 over 2. If I were to do cosine, however, of negative pi over 4, cosine of pi over 4 is radical 2 over 2, and cosine of negative pi over 4 is also radical 2 over 2. So it's just positive. So that's what that means when we're talking about those values. Here are the reciprocal identities. So sine is 1 over cosecant of t, and cosecant of t is 1 over sine of t. We kind of already touched on this, easy to remember. Cosine is 1 over secant of t, and secant of t is 1 over cosine of t. Tangent is 1 over cotangent, and cotangent is 1 over tangent. All right, the quotient identities, we again kind of touched on these already, but quotient is, tangent is sine of t over cosine of t. Let me rewrite. Sine over cosine. And then cotangent is cosine over sine. And that's because it's cosecant over secant. Pythagorean identities, these are ones that you're really going to have to remember. You're going to use these quite a lot, especially if you move on to higher grades of math. So this is going to be sine squared t plus cosine squared t equals 1. Now, just remember that we had this triangle at the very beginning. And so we said one side, let me draw the same thing. So we said one side was our y sine, and x is cosine. And we know that a squared plus b squared equals c squared. Well, sine squared plus cosine squared is going to be equal to 1 because that sine is always 1 because it's the radius. So that is where this equation comes from. So sine squared plus cosine squared equals 1. We can rearrange these, and so 1 plus tangent t is equal to secant of, this is tangent squared, is secant squared t. And then 1 plus cotangent squared t is equal to cosecant squared t. Now, if these next ones we're not going to do, so I'm just going to get rid of them. There's something I want to point out, though. I'm going to show you a little proof that we're actually going to do later, more so than we are now. But first thing, notice that this thing is the same thing as sine of t squared. This is what this means. So we're squaring those. I'm going to show you some tricks to remember these later. Okay, so we're going to use the unit circle to remember these trig properties. And we won't always have the unit circle with us, so we need to start remembering these properties on our own. So we've got sine of 5 pi over 6. So if you use your unit circle, you'll notice that this is 1/2. Okay, so then we have this identity, sine of negative 5 pi over 6. Instead of doing a bunch of math to figure that out, we can just know that we are going to end up with negative sine of 5 pi over 6 using that even and odd identity. So we get negative 1/2, which is just negative 1/2 for that value. Okay, so cosine of 2 pi over 3, that's equal to negative 1/2. Cosine of 2 pi over 3 is the same thing as cosine of 2 pi over 3. So we end up with, again, negative 1/2. It's the same value. All right, so we want to use the Pythagorean identity to solve for cosine of theta. So here I have sine of theta is equal to 7 over 8. We use sine squared theta plus cosine squared theta is equal to 1. That's the Pythagorean identity I'm going to use. So what I have is 7/8 squared plus cosine squared theta is equal to 1. So I'm going to do some math here. I'm going to square both of these. So I have 49 over 64 plus cosine squared theta is equal to 1. Just simplifying here. Next line, I'm going to do 1 minus 49 over 64. So I have cosine squared theta is equal to, what is 64 minus 49? 15, sound about right? Yep, 15 over 64. Okay, so then to finally solve, to get rid of that square root, I'm going to take square root of both sides. When we do that, we get cosine of theta is equal to radical 15 over 8. So I had to take the square root. Let me write that out. So this is the same thing as square root of 15 over square root of 64, which is the square root of 15 over 8. So that is what our cosine of theta is equal to. go ahead and try this next one on your own. So we have sine squared plus cosine squared equals 1. So we square both sides. We have 21 over 25 plus cosine squared theta equals 1. Subtract from both sides, we get cosine squared theta equals 4 over 25. Root both sides, and cosine of theta is equal to 2 over 5, which is a pretty neat trick. All right, so now we're going to have to figure out what identity we want to use. You'll have to start recognizing some of these before we get to them, but you'll notice that this is cosine and secant. These two things are inverses of each other. So we're going to use an inverse property. So cosine of 2.3 and secant is 1 over cosine of 2.3. So then these cancel and we're left with 1. With these problems, you are going to need to show all your work. Otherwise, you won't get credit for them. All right, this next one here is really easy. So we've got pi over 3 and pi over 3. So we have sine squared plus cosine squared equals 1. I just want to point out, if these two values don't match, so if we had sine squared of 2, let's just do pi over 4 plus cosine squared of pi over 3, this is not equal to 1. Just a note. Okay, and then finally we have cosecant minus cotangent pi over 6. So if I look at my original equation, so if I have 1 plus cotangent squared theta equals cosecant squared theta, that's not nice. This is the original Pythagorean identity. If I subtract cotangent squared from both sides, I get 1 equals cosecant squared theta minus cotangent squared theta, which is what I have here. And so that is equal to 1. So be aware that the identities might be hidden. Okay, and that's all for today, folks.